Friends, welcome to my YouTube channel. Dhanesh here. In this video I am going to discuss about the mathematics of back propagation algorithm. Back propagation algorithm is one of the most important algorithms in artificial neural networks. Related to artificial neural networks, we covered most of the videos like the architecture and how the artificial neural network works, and we have videos how you can apply the back propagation algorithm in simple neural networks. What should be happening at that time. See, in this video I am going to derive all the essential equations that's needed for the back propagation algorithm. To understand this back propagation, you need some of the important aspects you need to understand. Here is one is the chain rule from mathematics. I have a separate video for this chain rule. You can see it in I will include the link in the description. That is one is chain rule, and the second thing is gradient descent algorithm. So these two things it's needed to understand the back propagation algorithm. So you can watch the videos in the playlist. Even I can include the link of these two videos as well. So this is very important. Chain rule, I can tell you, for example, if you have a mathematical function, you can multiply it. See, this in simplest way I can tell dy by dx, I can write it as dy by dz into dz by dx. This is chain rule. This is very easy, and the practical examples also I have solved in that separate video. You can watch it. Fine, let's start. See, to understand this, one more aspect you need to understand related to the gradient descent algorithm. This is the complete concept, the complete equation describing gradient descent algorithm. That is, the updated weight, new weight should be equal to the old weight minus eta. Eta is the learning rate into dou e divided by dou w. E is the error or the cost function. Eta is the learning rate. Learning rate is the small baby steps we will take in the gradient descent algorithm to get the global minimum. Its value eta, it varies from 0 to 1, so in between it will come. So this is the most important equation you will be getting it for the gradient descent algorithm. You know it. If you don't know, you please watch those videos and learn gradient descent algorithm. Fine. And another thing you want to understand before getting into the back propagation algorithm is what exactly happening in the neural network. See, you will calculate, the weights and biases. Two important components coming here are the weights and biases. The first thing you do is you calculate the weighted sum in a neural network, in a artificial neuron. This is what happening in a neuron or a perceptron. What's happening is, first thing it's happening is you will calculate the weighted sum, and the second thing is you squash it using an activation function. You have different activation functions like sigmoid, hyperbolic tan, ReLU. Different activation functions are there. Even we have separate video, you can watch it, the complete mathematics behind all these activation functions. See, the weighted sum you will calculate and then squash it using the activation function. That's what you do in a perceptron or as artificial neuron. This is what usually happen. Now we will get into the back propagation algorithm. You understood what's the what's exactly it's happening neural network, and all those aspects you understood. See, the weighted sum means if you have x1, x2, x3 are the inputs, then w1 x1 plus w2 x2 plus w3 x3 like that it will go. This is the weighted sum. All right, then how do you squash it? You will, if you are using the sigmoid activation function, you know sigmoid, it is 1 by 1 plus e raised to minus x becomes minus z. Z is the weighted sum. w1 x1 plus w2 x2 plus w3 x3. So this, like this, you will squash it, because you will substitute the weighted sum instead of x. So this is the mathematics behind the simple neuron. That's what happening. Now we will get into the back propagation algorithm. So to understand more clearly, this is the architecture of a artificial neural network. You have the input layer, you have multiple hidden layers, hidden layer 1, hidden layer 2, output layer. All these are there. All the mathematical computation happening in the hidden layer. If through the input layer you will give the input, and here you can take the output from the output layer. This See, to understand the back propagation algorithm, I am having a block diagram. This is the simplest block diagram you can use. So you have the machine learning model. You are calculating the error using the cost function. So you have the cost function and you are calculating the error. If the error is minimum, if it is minimum, the model is ready for prediction. If it is not minimum, this block, it is really important. You need to update the weight and bias using gradient descent algorithm, and again you will calculate the error using cost function and again repeat it. So this is the complete representation of back propagation algorithm in a simple block diagram. So you have the machine learning model. You will calculate the error using cost function. If the error is minimum, the model is ready for prediction. If the error is not minimum, you need to update the weights and biases using the gradient descent algorithm. Again, calculate the error using cost function. This is the simplest representation of the back propagation algorithm. So I will explain it, more clearly, then you will understand it, in a easier way. So in the forward propagation, see, you have in a artificial neural network, you have the forward propagation and the backward propagation. In the previous videos, we discussed about forward propagation as well. See, when you move from input layer to output layer, see, this is the input layer and you are moving towards the output layer. Here we will calculate the predicted output and then calculate the error. That is what you do it in the forward propagation. Okay, so you move from the input layer to the output layer. Here the predicted output you will calculate, you will get it, and you will calculate the error. It is like, predicted minus actual. That is the error. That's what you do it in the forward propagation. But in the backward propagation, why we are using backward propagation? See, our goal, the machine learning model must be very good, must be excellent in prediction. For that, the cost function should be minimum. So to minimize the cost function only, we are using this back propagation algorithm. To minimize the cost function. How it is happening in back propagation algorithm? See, what we will do is we will go back. See, in the forward propagation, we moved from the input layer to the output layer. But in the back propagation, we will move from the output layer to the input layer through the hidden layers. So in the back propagation, we are going back, and as we have seen here, we will update the weights and bias using the gradient descent algorithm to minimize the cost function. So what we will do, we will go back from the output layer to input layer and update the weights and biases using gradient descent algorithm so that the cost function should be minimum. After backward propagation, we will be getting updated weights and biases. By using updated weights and biases, again, we will do the forward propagation and calculate the error, and we will check whether it is minimum or not. If it is not minimum, we will repeat the same process. This is the complete concept of back propagation algorithm. Now I will get into the mathematics behind this back propagation algorithm. To understand this, see the chain rule, you need it. One more thing, the log loss function. You can see the linear regression, sorry, logistic regression algorithm. I have the video there. I have, the log loss function and entropy function. It is clearly explained. Please watch it. So we need the equation for the log loss function here, and I am taking as, as the y cap, we are taking it as the predicted output. It is the predicted value, and y is the actual value. This is the symbol, this is the letters we are using in the entire this mathematical treatment. Y cap is the predicted value and y is the actual value. And the equation for sigmoid activation function. I am using the sigmoid activation function. The sigmoid activation function is 1 by 1 plus e raised to minus x. This is the sigmoid activation function. Here instead of x we will pass the weighted sum. Already I told you. So this also Now I am going to write the log loss function for this log loss function. It is L is equal to minus of y actual into log y cap is the predicted, minus 1 minus y into log 1 minus y cap. This is the equation for the log loss function. Minus of y into log y cap. Y is the, I already told you, y is the actual value, y cap is the predicted value, minus of, here it is plus, really sorry. See, I have taken minus of, right? So plus 1 minus y into log into 1 minus y cap. This is the equation. So now, the cost function. Most of the equations, the gradient descent equation, we used partial derivative. See, when you use partial derivative, when multiple variables comes into picture, the loss, the cost function depends on two parameters from the gradient descent algorithm. It is weights and bias. So the gradient descent algorithm, from that you understood the cost function depends on the weight and bias. Two things. See, from that you can understand it is, here we have the, Z is the weighted sum. I am taking a very simple network. It is the most simplest one. The more complicated networks, I have already given how you can apply this back propagation algorithm. Those videos already there, you can watch it. But this is the I am concentrating on the complete mathematics behind this. So you can write the chain rule. Based on the chain rule, the log loss function, we can write it as dou L by dou W. See, why I am writing dou L by dou W? Because from the gradient descent algorithm, the updated weight W of, see, we need to get the updated weights. In the back propagation algorithm, you need to get the new weight. The updated weight, new weight is equal to old weight minus eta into dou L by loss function into dou W. See, this is the equation from the gradient descent algorithm. So I am going to calculate this dou L by dou W. Then you can update the weights. The same thing for bias as well. B new is equal to B minus E eta into dou B by dou L by dou B. So it's the same equation. These two are from the gradient descent algorithm. This is for the bias. This is for the weight. This is dou L by dou B. This is dou L by dou W. W is the weight. So we need to get dou L by dou W and dou L by dou B. See, if you understand how you will calculate dou L by dou W, the same method only you are going to get it for dou L by dou B as well. Once you get these two, you can select the learning rate in between 0 and 1. Learning rate, it is, I already discussed. Then you can update the weights. You can keep on update the weights and you can come up with the minimum cost function. You can minimize the cost function. So how do you apply it in a more complex neural network? We have separate videos for that. You can watch it. I will give those links in the in the same playlist. You can see those videos. So this is what we are going to do. So now my aim is I am going to show you how you will calculate the dou L by dou W in this video. How you are going to calculate the error function dou L by dou W. See, the dou L by dou W, you need to understand dou L by dou W. You can write it as by chain rule. Dou L, the weights will depends on the, I can write it as dou y cap, the predicted output, into dou y cap divided by our predicted output. Y cap will depends on the weighted sum dou z, right, into dou z. Dou z depends on the weights dou W. So I can write the chain rule like this. This is the most important equation. So dou L by dou W, I can write it as dou L by dou y cap. Y cap is the predicted value, into dou y cap divided by dou z, because the y cap depends on the weighted sum. Alright, predicted output depends on the weighted sum, into dou z by dou W, because the weighted sum depends on the weights dou W. So this is the chain rule. We are going to use it here. Now we will separately calculate this dou L by dou y cap, this one, then we will multiply it, our final equation we will get it. So I am first calculating, see, dou L by dou y cap. So you have the log loss function. See, log loss function, we already have it. It is, L is equal to, I can write it as minus of y into log y cap plus 1 minus y into log 1 minus y cap. This is what you will get it as the log loss function. So when you take the derivative dou L by dou y cap minus of y into 1 by y cap logarithm derivative plus 1 minus y into again 1 by 1 minus y cap into minus 1. This is the thing you will get. Again, when you simplify it, you will get it as this minus and minus becomes plus. So you can write it as 1 minus y divided by 1 minus y cap minus y divided by y cap. So this is what you will get it for the dou L by dou y cap. So next I am going to calculate the next term. Next term is dou y cap by dou z. See, what is y cap? You know it. Y cap is the predicted output, that is, after squashing it, you will get it 1 by e raised to the squashing of the weighted sum. That is the predicted output from a simple neuron, right? Artificial neuron. What exactly is happening? You will calculate the weighted sum. After that, you will squash it using the activation function. Then you will get the output. Y cap is 1 by 1 plus e raised to minus z. Ez is, you can write it as w1 x1 plus w2 x2 plus w3 x3, like that it will go. So this is the predicted output. Then what is the dou y cap divided by dou z? So you need to apply the quotient rule. So it is the u by v into 1 plus e raised to minus z into 0 minus 1 into e raised to minus z minus 1 divided by 1 plus e raised to minus az the whole square. This is d by dx of u by v. That is v into du by dx minus u into dv by dx by v square. This is the quotient rule of calculus. We have separate videos for quotient rule, product rule, in differentiation in the playlist mathematics for machine learning. You can watch it. So this is the rule we applying here. Then you will get it as you will get the answer as is equal to e raised to minus az divided by, because this is 0, this is gone, this minus into minus plus, that is e raised to minus az plus 1 by e raised to minus az the whole square. Now I am going to change it. See, what I am doing is see, I can write it as the same thing. I am writing it as 1 plus e raised to minus az minus 1 divided by 1 plus e raised to minus az the whole square. So the same thing, this is what I have done. This one we have changed it like this. So this one again I can split it. So it would be this one I am going to write it like 1 by 1 plus e raised to minus az. I am going to split it 1 by 1 plus, so because I can split it like 1 plus e raised to minus az by 1 plus e raised to minus az the whole square minus 1 by 1 plus e raised to minus az the whole square. I am splitting like this. So 1 plus e raised to minus az by 1 plus, see this square and this is cancelled. This is 1 by 1 plus e raised to minus az. So the same thing I can again rewrite it as 1 by 1 plus e raised to minus az is it is y cap. So it is y cap minus, this is 1 by 1 plus e raised to minus az the whole square is y cap the whole square. So again we can take y cap common. So it would be, it is equal to y cap into 1 minus y cap. So this is the equation you got it for dou y cap by dou z. In the chain rule, again the third term you have written is dou z by dou w. So dou z by dou w, dou z by dou w is, see, if I am taking z is equal to wx, the simplest way, z is equal to, I am taking it as wx, only one input I am getting. This is the simplest network. Then dou z by dou w should be x, because w is the variable, so x is a constant here. So dou z by dou w. So you got all the three terms. Now we will multiply it. So when you multiply it, you can write it like this. Again, I will come to dou L by dou W. It is 1 minus y by 1 minus y cap minus y by y cap into the second term is y cap into 1 minus y cap. The third term is x into x. So this one I am taking LCM. This is the same thing. So this LCM and this thing will cancel. So this y cap will come here. 1 minus y into y cap minus y into 1 minus y cap. That you will get it here. I am putting it in a bracket. But this LCM and this will cancel. That's gone. Into x is remaining. Again, I am expanding inside. So y cap minus y into y cap minus y plus y into y cap into x. Again, minus y cap and this is cancelled. So finally, you will get it as so this one will becomes y cap minus y into x. This is the output. This is the final equation. This is really important. This is, the predicted minus, this is the actual. Y cap is the predicted value minus actual into input. That is the updation dou L by, see, we have what we have calculated for dou L by dou W. See, this dou L by dou W is the Y predicted minus Y actual into the input. X is the input, right? So this is the equation for dou L by dou W. So this update dou L by dou W, we will substitute it in this equation from gradient descent. That is weight new is equal to weight old, new weight, the updated weight is equal to minus eta into dou L by dou W. Whatever we got it now, dou L by dou W, we will substitute here and we will calculate the new weight. This is the math behind the back propagation algorithm. In the back propagation, we are updating the new weights and biases to get the minimum, to minimize the cost function, to get the global minimum, or to get the to minimize the cost function. So this here we will substitute and we will get the new weight, and this process repeats by using this block diagram. See, from this is a cyclic process. We will again repeat, and the same process for the math you can apply for bias as well. See, new bias is equal to old one minus eta into dou L by dou B. So this dou L by dou B, the same process you can calculate. See, we have the log loss function. Then after that you will calculate the same chain rule you can apply for dou L by dou B is into dou L by dou Y cap into dou Y cap by dou B into dou B by dou W. The same chain rule you can apply it and come up with the dou L by dou B. Then you can come up with the new bias as well. So this is the math behind the back propagation algorithm. We have separate videos. I have already put it in the playlist. How you can apply this is, we have put only one input X. When you have multiple inputs, little more complex, neural network, how do you apply it? We have separate videos for that. Please watch it. So I have covered the complete math behind the back propagation algorithm. Thanks for watching. Please subscribe my channel.